Okay, welcome to the NUPOC Video Study Guide number 78. I think in the last video, or a couple videos ago, we talked about doing some basic circuit analysis, and I mentioned that I was using Kirchhoff's laws, I think KVL or KCL, something like that, and that I would come back in a couple videos and do an explanation in a little bit more detail about exactly how to use KCL and KVL, or Kirchhoff's current law and Kirchhoff's voltage law, to analyze basic circuits. And this is actually a problem in the Navy study guides. It's actually question 5 in the EE section of Guide 2. So there are two of Kirchhoff's circuit laws, and I'll say the first is Kirchhoff's current law, or KCL, right? And this basically just says that the sum of the currents, entering some node, entering or leaving, it depends on what convention you use, entering a node equals 0, right? So if I have some circuit, and maybe I have like some resistor here, and then some capacitor here, and then some inductor here, doesn't really matter. This is a node, right? This junction where all the wires come together, and so if I look at all the currents entering that node, they must equal 0. Of course, that also means I could look at all the currents leaving the node, and they would just have the opposite sign. So if this is 1 amp going in, it's also minus 1 amp leaving. So if I summed all the currents exiting the node, that would also be 0. Another way to write this is that the sum of currents entering a node equals the currents leaving a node. So I might have 1 amp going in here, and then half an amp leaving in this direction, and then another half an amp leaving in this direction, something like that. And so the sum of all the currents leaving, this half an amp and this half an amp, equal the sum of the currents entering, which is just 1 amp. And then we have Kirchhoff's voltage law, or KVL, which basically says the sum of the voltages of all the elements around a loop equals 0. So if we have some basic circuit where we have, let's say, a voltage source like this, and then maybe a resistor and capacitor or something, again, it doesn't really matter, right? I'll have some voltage on this source here, and then there'll be some voltage on this resistor and some voltage on the capacitor, and if I go around this loop and I add up all these voltages, it needs to equal 0. So when I go by a source like this, as I'm going around the loop, when I pass by a source and I go from negative to positive, I add it because it's a voltage rise. So if this is voltage V here, I would say plus V, and then if this is like VR and this is VC, okay, I would then subtract VR, right, because it's a voltage drop. It goes from positive to negative. And then I'd also subtract VC, and that this is the sum of all the voltages around this loop, and that must equal 0. And similar to KCL, I could also phrase this as saying the sum of all the voltage rises must equal the sum of all the voltage drops. So I could just move minus VR and minus VC to the other side and write something like this, right? And if I want to, going back to the KCL case, if I want to actually label all this stuff, right, maybe this is IR, this is IL, and this is IC, right? I could put maybe IR, if we want to look at the currents entering the node as having a positive sign, and these two currents are leaving the node, it'd be IR minus IL minus IC equals 0, or IR equals IL plus IC. And so if you have some sort of basic circuit, you can use KCL and KVL to come up with equations that will help you solve it. So in general, if you have a circuit that has like a lot of things connected in parallel, it makes more sense to use KCL because you have some node, right? Like this. Or if I even had another resistor here, or however many resistors, right? I've got a node here and a node here, right? So I can go ahead and sum all the currents at this node and then sum all the currents at this node. And so I might say something like, if this is I1, right? And then this is, I don't know, I2 or something, and I3, and maybe this is IR1. I could start writing equations like, I1 equals I2 plus IR1, which is just V over R1. And then I could keep doing my analysis from there. And if I have a circuit that has a lot of things in series, maybe even like 3 resistors or whatever, doesn't really matter, it makes more sense to use KVL, or Kirchhoff's voltage law, and write an equation going around this loop. So, maybe this is VR1, VR2, VR3, and so I could start by writing something like V equals VR1 plus VR2 plus VR3, and then I could start substituting things in, like there's some current here. I know that I equals V divided by R1 plus R2 plus R3, and then I could also say up here that V equals I times R1 plus I times R2, I times R2, like that, plus I times R3, right? And if I want to find maybe VR1 or something like that, we could go ahead and do that. But this is the equation right here that we are getting from KVL. And again, it makes more sense to use KVL when we have lots of things in series. And then for this case, this is the equation, more or less. I subbed in V over R1 for IR1 here. But this is the equation that we're getting from KCL, and this is the equation we're getting from KVL. And KCL makes more sense for lots of things in parallel, and KVL makes more sense when we have lots of things in series. So I hope that works. If you have more questions, just comment below, and of course be sure to click this button down here to subscribe so you don't miss the upcoming videos and study tips.